Welcome back to part 4 of the SVG to Geometry Nodes series. In this part, this is going to be the final part. In this part, we're going to take a look at how to take our bent logo that we had in part 3 that we prepared and project it onto a cylindrical object in Blender and then emboss or engrave it into the surface. So just to recap, in part 1, we simply learned how to take an SVG file, like a logo, into Blender and turn it into a 3D shape with geometry nodes. In part 2, we took that and projected it onto a flat surface and engraved it into the surface. In part 3, we created this bent version of the logo, also using geometry nodes and a lot of math nodes to prepare us for projecting this and having all the control over how we bend this onto a cylindrical shape. And that's what we're going to do in this part 4. And then we're going to be done and we have all the control and all the options we want. So to get started, I just want to clean up our annotations by removing this layer. And that gets rid of that. And I don't even have a cylindrical object yet, so let's add that. And I think I can just keep it simple and add a mesh primitive cylinder for this. And in object mode, scale it up a little bit. I don't know, maybe something like this. And then we can take our logo. And the whole goal is maybe a little bit bigger. So the whole goal is to be able to take this object and have very easy control over where you place it and where and how it's bent like this, and then place it exactly where you need relative to this cylinder and then engrave it into the surface. So in part 2, we were doing this with this cube object, which had some flat surfaces. So let's take a look at that. And currently it is not showing up, and that's because we turned off the display. We turned off the viewport, which is similar to hiding it, but it also removes all the calculations. And you can see the Boolean calculation, which was very slow, is still turned on. So first I'm going to turn that off, and then I'm going to enable it. Otherwise, enabling this would take like 5 seconds. So with this, I'm gonna select this and then select the cylinder as well and make sure the cube is the active one. Then you can hit Control-L to link the, to copy the modifiers. And you can use a lot of other stuff like link materials and things like that. But I wanna just copy the modifiers so that we have a similar kind of object here. And now I can hide the cube again because I don't need it. That's just to get a starting point here. And this adds a little bit more density to the mesh, which is good. It adds some displacement to show off the procedural nature of all the things we're gonna do. And it's gonna be reactive and fully procedural and non-destructive, so that's cool. I think the displacement is a little bit extreme, so let's turn off the small displays first and tweak the large displays. And I think I can turn down the strength to something like 0.5. And then the small displays for more detail, let's turn it on and also lower that quite a bit. Something like this. This just gives us a little bit of a random surface to not have a perfect shape to work with and still making it work with the flexibility of geometry nodes. And then the last modifier is an engrave path geometry nodes tree that we created in part 2. And I just want to reuse most of this stuff. So what I'm going to do is create a copy by hitting this 2, and then I'm going to change the name. So what we did in part 2 is take a raw path or curve object and engraved it into the cube. In this case, we can't do that because this logo, because it's bent, it already has to be a mesh. We cannot bend a curve and then turn it into a mesh because that flattens it out again. that kind of turns it into 2D. That's what we saw in part 3, I believe. And so therefore, this is already a mesh. And what I want to do is I want to apply the geometry nodes to this cylindrical object, because that's the object we're essentially modifying. And I want to do it based off of this logo, which is a mesh. So this engrave path needs a path object. So instead, like, let's rename it to engrave mesh, and maybe also specify that it's for cylinders. So something like this, into cylinder, just to keep it very descriptive and clear what we're doing. Okay, so this is going to engrave a mesh into a cylinder. And if you look at these nodes, you can already see there's some warning marks here, or information. And that's because this object, this path object, which is also a wrong name, let's rename that. This is going to be a mesh. Let's call it the engrave object. This engrave object, or maybe call it mesh, engrave mesh. So that's clear that it's a mesh. This is set to the Blender Grid logo at the moment, which is good, but that is a mesh. So then we're taking this and here we're setting the spline resolution on a mesh, which doesn't make any sense. So we can remove this with Control X, and set spline type also doesn't make any sense. Fill curve, it's not a curve, it's already a mesh, so that doesn't make sense. Then we can subdivide the mesh, and that is fine to add some more detail, to add some more resolution to the mesh. So let's take a look at what we have at this stage with a viewer node. And I hit Control-Shift-Click on this to quickly add a viewer node. And as you can see, the logo is a little bit messed up because of this subdivide node. If we disable that, it looks good, but enabling that will screw up some of those faces. And that's because those faces are n-gons, and n-gons can be concave sometimes. Ideally, the faces of a mesh are convex, but in this case, wherever you see the faces kind of messed up, it's because the n-gons are concave. So to fix that, we're gonna go back to the logo, and that disables the viewer nodes, and now we see the cylinder again. And we're gonna look at curve to mesh, and we have two modifiers. I think the curve to mesh is where we set the face type, and here we see this node. We have it set to n-gons. If we change this to triangles and then go back and look at our viewer node, now everything looks fine, even with a subdivide node. And you can see that this adds a little bit of geometry inside of there. And that's actually useful, so I'm gonna keep that. Next up is a transform geometry node, and we do that based on the location. And that's because in part 2, we were working with a curve at this stage, and we had to do some fixes to fix the fact that a curve is the z coordinates of the curve are reset to 0 whenever we turn it into a mesh, and that's what we had to fix with this. So right now we already have a mesh, and it's already in the right location, so we don't need this. So we can remove this. We can remove this one, and we're going to simplify this a whole lot. And here we are working with a raycast node on the original geometry, which is the cylinder, and that's our target geometry, so that's fine. Then we're going to take this hit position, and we're going to set the position of this. And let's take a viewer node over here and see what we get. And this looks like nothing is going on, but actually, we don't see anything, because what we see here is our original Blender Grid logo object. If we hide that, we don't see anything because our raycast is set to, the ray direction is set to the negative Z direction. So that's straight down. And currently, we're trying to take our logo and cast rays straight down and try to hit our cylinder. But we're never going to hit that cylinder because our cylinder is sitting over here like this. So we're never hitting the cylinder. So to test if this is working, we can simply change the ray direction to something else. So instead of -z, I want to just hit it in the Y direction, the direction of the green arrow. So let's set this to 1 and the Z to 0. And now you can see we actually get something here that looks kind of okay. But here you can see the D is kind of deforming in a not so nice way. And if your surface is barely curved, so if this logo would be very small, then this would be fine. And you can actually also, let's take our bend center and move that out a little bit. Something like this would work. And then you're pretty much doing the same thing that we did in part 2 and you're done. I want to take it a little bit further and use a different kind of ray casting. So what I want to do is, let's take a look from the top. And actually, I want to be able to see my bend center in the middle of our cube. So the way you can do that is go to viewport display and set this in front. And this way you can always see it, even if it's behind inside of our cylinder. So I can kind of send this to the center of the cylinder, which would make the most sense. But what I want to do, let's take a look from the top again. What I want to do is I want to, instead of ray casting all the points in this direction or a set constant direction, instead of that, I want to point all these points into the direction of our control center, our bend center. So here they will move a little bit like this. That just gives us a little bit cleaner result. It has some downsides, but I want to just explore this option instead of moving everything in a set, in a constant direction. So let's try that. The way to do that is I want to do it completely based on our bend center. So it would be nice to have this bend center location available in our node tree. And the way to do that is simply getting another object info node and choosing that bend center. But instead of choosing it here, I want to be able to expose it to the outside so we can set it over here. And let's rename this first to center object and move it 1 up so it's right below our engrave mesh. And the center object is going to be our bend center. And now we have access to the location of that object. And I want to make sure this is set to relative, because then we can move the cylinder around and the bend center will still be relatively correct. So yeah, if the cylinder is exactly in the center of the world and it's not rotated, it's not scaled, then it doesn't really matter. But the moment we're going to move our cylinder, you want to make sure this is set to relative, because that makes it work correctly. All right, so how do you get this blue arrow direction? First, you need the point on the mesh here on this logo, and then you need the location of this bend center, and you kind of need the difference between them. So we can use a vector math node and use subtract. So first we're going to take our object info, take that, and we want to subtract the location on the mesh, and that's simply a position node. And this position node can be any position, so it depends what we connect this to. But if we set this to the ray direction, it's going to look at our set position, and it's going to kind of go backwards and take this position, and it's going to try to get the position from the ray cast, and that means it's going to try to get the position from here, and that means the position that we have here is now in the context of our logo object. So, and you can see it's already working. It's already moving in the right direction. And what you can see is one of the downsides of this approach, which is the logo looks a little bit smaller now. And that actually makes sense, because if we look at this from the top, and let's reset my node here. So we're looking at this from the top, and if you have your logo and you move everything in this direction and everything here in this direction, like this, the closer you come to this center point, the smaller the logo is going to be. So that is the downside of this approach, but it's other than that, it's quite flexible. And to mitigate this, you can always scale up the logo or move it closer to the surface, and that fixes it. So let's move this back to the center, and now we can see the logo is completely projected onto this cylindrical surface. And yeah, that works quite well. So we simply take the position and we subtract it from the location of the center object, and that gives us the right ray direction. And you might think these vectors are not normalized, they don't have a length of 1, but I don't think that matters for the ray direction. The ray direction only cares about the direction of the vector, not the length. But if you're concerned about that, you can always add a second math node and normalize it like this. And as you can see, that doesn't really do anything. So I don't think that really makes a difference, because the ray direction, I believe internally this already normalizes the vectors. So that is that. And yeah, again, the logo is slightly smaller because of this approach, but I think it's a very robust approach to project flat or project this onto a cylindrical surface. One other thing you might notice is that if you look at this from the top, it looks like, yeah, we want to be moving this position in that direction. We want to move this position in that direction. But if you look at this from the side view, the top of this D is moving also in this direction of this point. So it's kind of moving down a little bit like this. And the bottom of this G is moving up a little bit. Is that a problem? Or should we try to make it move in and project it in this direction all parallel because of this cylindrical shape? And we can try to do it in parallel, but I'll show you what happens when you do that. So we only need one node to do this, another vector math node. And if we add this here, we can set it to multiply, and by default it's set to 0, but we want to multiply the x to 1, we want to multiply y to 1, and we want to multiply z to 0 to remove any of this remove any z component of these vectors, and that kind of flattens them out horizontally. So now we have a more of a cylindrical projection going on, and I don't really see the issue right now, but maybe if I scale this logo up a little bit, we can start to see the problem. And I also move our control point back something like that, and maybe move it out a little bit. Something like that. Now you can start to see the issue here. So the logo is getting significantly smaller in this X direction. It's scaled down in the X direction because of this projection going to a single point. But in the Z direction, it's not scaled down right now because we're using this parallel method, because we're flattening out these vectors. And that's actually not what we want to do, because now we're kind of squishing down the logo into the X direction. We're scaling it down only in the X direction, and that kind of deforms the logo. And these are supposed to be circular, but they're a bit squished right now. So that is not the right approach. So in this case, it's easier to just keep it simple and not worry about this. And that kind of fixes the problem. Now it scales down in both directions the same way. And yeah, by keeping it simple, that's the solution in this case. But yeah, in case you were wondering, that's why I'm not doing that. So now we have a pretty good way to control the placement of our logo. We can scale it, we can rotate it, we can move this point around, this center point. And actually, if you remember in part 3, we disabled the Y direction, but now let's enable it, because now this gives us an extra control over this placement if we would ever need that. So now we have all the control we need on placing our logo. And also when we place or when we move our cylinder or rotate it or anything, everything responds and everything is procedural. So that's really nice. And yeah, maybe I should show what happens when you don't set this to relative. Right now it looks fine, but if you move this, then things start to break down, and that might be what you want, but to keep easy control, it's better to set this to relative, but because now the position of this logo is controlling where we are placing and the position of this point is determining how things are projected. All right. The next thing is to look at the actually turning this into 3D, and I think it already happens. Yeah. So when we look at, let's say, solidify mesh, let's put a viewer node there and look at the 3D shape of this logo right now. It kind of looks pretty bad because the direction in which the faces are extruded is kind of weird. And that's simply because in part 2, we were blending between a blurred version of the normal of the surface and a hard-coded vector here that's set to the positive Z direction. And that doesn't really make sense in this case because we're projecting horizontally now. So if we would blend this back to only the normal direction, that actually fixes our entire problem. So we don't even need this mix node. We don't need this vector. We can just remove this and again simplify things. I still think blurring this because of the nature of the random noisy surface, blending this or blurring this is a good idea. So I'm just going to keep that. And then we are scaling it down in a negative direction to give us an offset. This will, let's see what this does. This will move it inside of the surface a little bit. So if we look at that, oh no, actually let's see, if we don't use this, yeah. Wait, if we set this to 0, what would happen? Okay, this sets it to the surface and minus 0.1 moves it into the object. And that's because we want to engrave this. And then here we're extruding it slightly more than the negative 0.1, just to move it outside of the surface a little bit. And that makes it easier to do the Boolean operation. So I think we're in a good spot to check out what happens when we turn on the Boolean. And then we can engrave our logo into this cylindrical surface. So we have set this switch, that's what we did in part 2, which allows us to use Boolean and have this checkbox here. So let's take a look at that and see what happens when we turn that on. And that takes like a couple seconds because it's not just the Boolean, but it's the self-intersection, which makes it a lot slower. But in part 2, we saw that we needed that in this case, with this type of geometry. And that looks really good. That looks pretty clean as far as Boolean operations go. Cool. That concludes the SVG to Blender to Geometry Nodes series. I hope this was useful. Now we know how to get an SVG into Blender, turn it into 3D with geometry nodes and have all the control that that gives you. Keep it completely procedural. Use geometry nodes to emboss and engrave it into different types of surfaces, flat surfaces, cylindrical surfaces. Learn how we can bend the logo, and yeah, I hope that gives you a lot of flexibility and allows you to do anything you need to do with your SVG files in Blender. I hope you enjoyed this, and I will see you later.